Hi, so today we're going to be working on the missing energy lab. So the purpose of this lab is to find the missing energy of a rolling ball. We have a meter stick, a basketball, a ramp, a couple of books to raise the ramp up, and
set up the lab according to the diagram shown here. To start off the lab, begin by taking the mass of the basketball. The scale is in grams, so make sure to convert the number into kilograms. Take note of the mass, as you will use it later for your calculations. Trial 1, decide on the height of your ramp and use just like we did here. Then measure the height of the ramp from the top of the ramp to the floor in centimeters. Don't forget that you have to convert those centimeters into meters. After that, measure the length of the entire ramp. This length will stay the same for all 3 trials. Take note of both the height and the length of the ramp. Once you have measured this, place the basketball on the ramp and let it go. As the ball rolls down the ramp, use a timer to measure how long it takes to roll down the ramp and reach the floor. Repeat these exact steps for trials 2 and 3, but make sure to change the height of the ramp. Lastly, you're going to have to fill out the data table. The height, length, and time columns will be easy to fill out because that was measured during the lab. Using the formulas and calculations that we will show in a second, find the additional components of the data table. To find acceleration, use the kinematic equation x is equal to x naught plus vx naught plus 1/2 ax t squared, and then solve the equation to isolate for acceleration. Find the speed at the bottom of the ramp, use the kinematics equation vx is equal to vx naught plus ax t, and then substitute the a with 2x over t squared. Then simplify the equation and you get vx is equal to 2x over t. When the ball was measured on the scale, the mass was 0.5 kilograms. To find theta, you will use the length and the height, L. Theta is found by taking the inverse sine of height over length. To find the translational kinetic energy, you use the equation 1/2 mv squared. Next, to find the initial gravitational potential energy, you use the equation mgh, where g is equal to 9.8. For the lost gravitational potential energy, it is the same equation as the initial gravitational potential energy, which is mgh, where g is equal to 9.8. And finally, to find the missing energy, we use the equation gravitational potential energy minus the kinetic energy, which is also equal to mgh minus 1/2 mv squared.
so K gain is our Y, and then we have the UG as our UG lost as our X. So here we have a graph of with a positive correlation, and we used a linear regression to draw a line of best fit through the points, and we got the equation K gain equals 0.226468 UG lost plus 0.536191. So the value of the slope of the graph should be 1, and because the gravitational potential energy gets transferred to translational kinetic energy in a 1-to-1 ratio, while the value of the slope of the graph actually is not 1, because there's a energy loss from the gravitational potential energy to translational kinetic energy. And the missing energy is actually going into the rotational kinetic energy because the ball is rolling.